Hello everyone, welcome back to my channel Kitchen Chemistry with Imabest. In our last video, we talked about hydrocarbons, their classification, general formula, and basic naming like the meth, the eth, the prop, and others. Remember, for alkanes, we have the ANE, for alkanes, ENE, and for alkyne, we have YNE. Please don't forget that. So today we'll understand where the substituents like methyl, ethyl, propyl, and others come from. So what are substituents? In organic chemistry, a substituent is an atom or group of atoms that replaces what? Hydrogen atom on a main carbon chain. So to understand these substituents clearly, we'll start with alkanes. Remember in our last video, alkanes have general formula CnH2n plus 2, and they contains what? Only single bond. Then where n is what? N is the number of carbon atom in the hydrocarbon. Don't forget this. So we'll start with alkanes. This is it. We have from alkane to alkyl. How do we get to that? So we have from alkane to alkyl. This is what? Substituents. How do we get to this? So alkane, for example, let's start from methane. The meth now, that is one carbon atom. That is one carbon atom. So if this is methane, CH, remember the our general formula. That is why I started explaining the alkanes again, what we did in our last video. Please don't forget that. So this is methane, that is the alkane now. This is methane. So how do we get an alkyl group? It's just when one hydrogen atom is what? Is removed from alkane. Do you understand? When one hydrogen atom, I'm not talking about carbon atom, when one hydrogen atom is being removed from the alkane, we have an alkyl group. That is the substituent we are talking about. So this is it. If we remove one hydrogen from here, we'll have what? No more CH4, CH3. This is what? Methyl. Remember, this is methane. And this is methyl, a substituent. Can you spot the difference between the two? Can you tell me what you notice here? This and this. So when you remove one hydrogen from an alkane, the name changes to what? YL. So you simply do what? You replace ANE with YL. Simple. You replace ANE with YL. Methane, methyl. Methane, methyl. To get a methyl group, you remove one hydrogen from methane. you have what? The methyl group. This substituent is very important because we'll be using this substituent to name the branched chain. So that is why I have to bring this before we start naming proper, because you'll be seeing methyl, ethyl, propyl, and others. So I don't want you to get confused. So just understand this very well. To get an alkyl group, you remove what? One is just a removal of what? One hydrogen atom from an alkane. You have what? An alkyl group. That is the substituent. Can we try another example? Okay, let's look at another example. We started with methane. So we'll take ethane. That is 2 carbon atoms. Yeah. Don't worry, you understand. I'll break it down for you to understand very well. Yeah. So if we say ethane, this is the F. Remember? 2 carbon atoms. Don't forget that. So this is what? If you use the general formula, remember ethane is what? C2H6. Use your general formula to confirm that. Yeah. So this is ethane. If one hydrogen atom is removed from here, we'll have what? C2H5. This shows that this dash shows that it is being attached to a main chain. It's being attached. Sometimes you see a structure like this, and this is it. You see something like this. This is a methyl group. So this is just to show that this is attached somewhere. It's attached to the main carbon chain. So you'll be seeing CH3, this C2H6. Don't be confused. This means there is an attachment. This is an attachment. This is being attached to something. Yeah. So C2H5. This is what? Ethyl. This is just simple. If you follow it up one by one, you understand. This is it. ANEYL. So this is YL, and this is what? ANE. Removal of what? One hydrogen atom from alkane. Yeah. So can you try 3 carbon atom or 4 carbon atoms? You can try that for me. That is a butane. Yeah. 4 carbon atom. Butane. Can you try that for me? From the name but. How many carbon atoms? 4. Don't forget that. So use the general formula and write that structure. Then remove 1 hydrogen from the butane and tell me what you have. Hydrogen is what? C4H. Just try that. Let me see. Okay, let's do it together. C4H10. Yeah. I think you have that. Yes. So this is butane. Right? From here, if you remove 1 hydrogen from the from butane, what do we have? C4H9. Is that what you have? C4H9. And this is butyl. This is being replaced with this. Chemistry is just straightforward. The more you do it, the more you understand it. It is always from this to another. If you don't understand a particular step, you will miss. So you have to follow me step by step. We'll take it step by step. I'll break it down for you to understand. You don't just jump. You don't move to another topic like that. You don't jump to another thing. You understand it one by one. It's step by step. We did naming. We did, at least we introduced naming. We've not started the main naming yet, but I think I introduced that. We saw the classification and naming the general formula, using the general formula to know the structures. Yeah. So if you don't understand that, then you'll be so confused. Yeah. So you have to understand these substituents. You have to be serious. You understand these substituents very well. Naming will be very simple for you. Yeah. So please take it very serious. So we'll do another example. How many carbon atoms are we looking at? Number 4 example. Okay, let's try 8 carbon atoms. Tell me the number of hydrogen atoms that is there. That is the octane. Yeah, I know you're asking yourself, is it only alkanes or is it only alkyl that have substituents? No, even alkenes too, but for now we'll focus on alkyl substituents because they're the simplest. And as we progress, you'll be seeing other substituents like the alkanes and the alkynes. Yeah, we'll take that step by step. So these ones are the simplest. So we'll get to that. Yeah. This is octane, 8 carbon atoms. This is the from the name, that is 8 carbon atoms. Yeah. So if this is C8, hydrogen will be what? Can you use the general formula to confirm that for me? C8H what? 1, 2. Apart from going back to use a general formula to do the solving, immediately you see the number of carbon atom. Yeah, let me show you these other parts. Immediately you see the number of carbon atoms, and they said what is the number of hydrogen atom that is there. What do? You just count the number of carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8. I remember our rules. Remember this rule? Carbon must have how many bonds? 4. Don't forget that. So here we have the 8 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8. You'll be putting the bonds, right? Remember, we're talking about just hydrogen atoms. Let me show you another way. Sorry, that is a bond. So that each carbon atom is surrounded by how many bonds? 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Complete. So if you add your hydrogen, this is another way of getting that. I don't know, because when you get to like maybe more than the carbon atom, maybe if you get to like 20 something carbon atoms, you will not be needing, like it will be very long for you, like the process will be very long. So that is why the general formula is coming. Yeah, so you can use that to calculate that. Yeah, but since we don't have much carbon atoms, you can easily do this. Yeah, so if you count the hydrogen atoms, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So our hydrogen atom there is what? 18. Yeah, so this is what? Octane. So if you remove one hydrogen from there, what do we have? Let me do that one. Sorry. Seventeen. This is alkyl. The YL is it. That's just it. Yeah. So if you understand this very well, you will not have any problem. Substituent. This substituent is very, very important. We'll be using this to name the branched hydrocarbons. So you have to get this. You have to understand this very well. Let's look at this table. So the alkyl substituent is what? From methane, you're replacing it, right? Methyl. Remember? Ethyl. Propyl. Butyl. Pentyl. Hexyl. Heptyl. Etc. So we have more. So this is it: the methyl, the ethyl, the propyl, butyl, pentyl, hexyl, and heptyl. Then others. Then the formula, the one we just did. If let me include this before. I should have included it here. How do we do that? Okay, don't worry. You are what we just did. So the formula, the methane was CH4 before, that is methane, an alkane. Then when you remove one hydrogen from it, we have the methyl here. So this is the formula. Sorry about that. Let's use this for this. So this is CH3 for the methyl. Ethyl is what? C2H5. You maintain the carbon atom for C5, C6, C7. So for the propyl, propane was what? C3H8, right? C3H8. So if you remove one hydrogen, we have C3H7. Butane was C4H10. Now, if you remove one hydrogen from there, you have H9. This was C5H12. Remember? Then if you remove one hydrogen from there, you have C5H11. C5H11. Our hexane was how many carbon atoms? That is 6. Then how many hydrogen atoms? 14, right? So if you remove one hydrogen atom from there, you have C6H. So you are following what I'm doing. Yeah, so for the heptyl, heptane is seven carbon atoms. Yeah, 7 carbon atoms was how many hydrogen atoms before? Before was what? 16. C7H16. You remove one hydrogen atom, how many will you have? C7H 15. You can use this to continue other carbon atoms. As far as you know this, the naming will be very easy for you. Yes. So this is a table I have for you. The alkanes, yeah, the alkyl substituents, the methyl, the ethyl, the propyl, the butyl, and others. Then the formula. Just remove one hydrogen from the former, like the methane. You remove one hydrogen from there. You have the methyl. Ethane. You remove one hydrogen from there. It will turn to what? Ethyl. The propyl, the same thing, and others. So please don't forget this table. There is something I want to show you. I know students will always look for the simplest way of getting something. Yeah, this is from me to you. Yes, so because sometimes you will not really have the time to use the general formula to do the calculations, and or you try to draw the way I just showed you. You draw the carbon atoms and you add those bonds and you start counting. All those things will waste your time. So this is how I do mine. So okay, this is it. If this is methane, right? What I want to show you is how to know the number of carbon atoms and hydrogen atoms without doing the calculations and whatever. So this is it. I will say this is the first carbon atom. This is 1. So if you increase the carbon atom by 1, this is what? See, to remember, this is 1 carbon atom. This is 2 carbon atoms. Now you are increasing from 1 to 2. You are increasing it by 1. That is 1 plus 1. That is 1, 2. You understand? 1, 2, 3, 4. You keep increasing it by 1. If you increase the carbon atoms by 1, what do you do to the hydrogen atom? You do what? You increase the hydrogen atom by 2. With this, you know the structures. You don't need to calculate it. Okay, let's look at that. So this is, if this is C2H, if this was 4 hydrogen atoms, if you add 2 to 4 is what? 6. This is our ethane. Do you understand what I mean? You increase the carbon atom by 1 and increase the hydrogen atom by 2. Increase the number of carbon atom by 1 and increase the number of hydrogen atom by 2. Very simple. That's the simplest way of getting those things. So okay, let's look at it. Okay, let's see. See, from methane, this is methane. If you increase this by 1, that is 2. Hydrogen, 4 plus 2, 6. Our next carbon atom is what? 3. That is ethane. 1, 2, 3. Hydrogen will be what? 6 plus 2. That is what? 8. propane. Our butane, that is 4. This is 1, 2, 3. You keep increasing the number of carbon atom by 1. You keep adding 1 carbon atom to this. So this is C4. H, this side is increased by what? 2. 8 plus 2, 10. Very simple. This is C, you increase it by 1. This is 5. What will be here? 10 plus 2. This is what? 12. C6, H what? If this is 12, this will be what? 14. C7H, if this is 14, this will be what? 16. So this is it. This is the simplest way of getting it. Then to get the alkyl group is just to do what? You keep removing 1 hydrogen. This is what? 3. This was 6 before, turns to 5. This was 8, 7. This was 10, 9. This was 12, 11. This was 14, 13. This was 16, 15. Very simple. So just use this and off you go. You understand it. So if they say if the carbon atom is 22 and you already know that you already know if C is 21 and you know the number of hydrogen, C22 will be what? You increase the number of hydrogen by 2. You add 2 to it. No matter how the carbon atom be long, you will know the number of hydrogen atom that is there. Very simple. You increase the number of carbon atom by 1 and what? And increase the number of hydrogen atom by 2. Very simple. Okay, so let's look at one structure. If you see a structure like this, 1, 2, 3. When you know all these things, there's no way you see a structure that you cannot analyze. I keep telling you. So if you see a structure like this, okay, this is another one, hydrogen, 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 hydrogen. This is another hydrogen here, hydrogen here, hydrogen. Look at this structure very well. What are you seeing there? First, look at the structure very well. If you see a structure like this, what is this structure? Carbon to hydrogen. These 3 carbon atoms surrounded by what? Hydrogen atoms. Number 1. If you look at the structure very well, what do you see there? Number 1 is what? This is an hydrocarbon. Yes, hydrogen and what? Carbon. Carbon to hydrogen, carbon to hydrogen. Everything you're seeing here is what? Carbon and hydrogen. There is no other atom. Yeah. So number 2 is what? What can you see here in this structure? 1, 2, 3. There are 3 carbon atoms here. 3 carbon atoms. This is what we've been doing. So if you understand these things very well, you will see a particular structure and you're like, okay. You understand what is happening there. So this is 3 carbon atoms, and 3 carbon atom is what? Propane. That won't look strange to you. Yeah. Then the next thing is what? Look at it very well. What is that? That is a substituent. Yeah. Remember I said the substituent will be used to do what? To name what? Branch hydrocarbons. This is it. This substituent is what? We know it's an alkyl substituent. Yeah, it's what? How many carbon atoms is here? 1. That is 1. So it's what? Methyl. Because if you count the hydrogen atom that surrounds the carbon, is how many? 1, 2, 3. This is a methyl. Methyl substituent. Yeah. So you see a structure. Number 1, you look at the carbon number of carbon atoms. After identifying the structure, how many carbon atoms are there? So propane is how many? C3H. This is propane. But here there is an attachment in this structure. There is a substituent in this structure, which is methyl. This is it. So if I didn't introduce this substituent and you see this structure, you just be looking at it and say, where is this one coming from? You see? So when we get to naming, you understand it more. So this is our word. 1, 2. There are rules in naming. We will get to that. You understand better. So, but if you're naming this is what? So this methyl is attached to number 2 carbon atom. So this is what? 2-methyl number of carbon atom 3. This is propane. 2-methyl so this is the name. 2-methyl propane. Very simple. And even if they don't give you this structure, you just see the name. Number 1 thing you should look at when you see a particular name like this, first of all, identify the parent name that is there. The N, the prop, the N. This is an alkane. Yeah, and prop is what? 3 carbon atoms. Because this is ANE, not ENE. If there is ENE, you know that there is at least 1 carbon to carbon double bond. There is a double bond, at least 1 double bond in that structure. If this was in ENE. Then if you have YNE, at least 1 triple bond, carbon to carbon triple bond. So the first thing you should consider here is the parent name, the alkane. Is it an alkane? Is it alkene? Is it alkyne? So because it's an alkane, the ANE is just a single bond, not double, not triple, a single bond. This is, you know that it's a single bond first. This is a single bond. Then how many carbon atoms are we talking about? The prop, that is 3 carbon atoms. First, you do what? First, since we know it's a single bond, because of the ANE, and we know is a 3 carbon atoms, what do? 1, 2, 3. You can add your substituents. You can add your hydrogens. This is what should come to you first. Then you see 2-methyl. You see there is a substituent YL. Remember, YL shows it. YL is what? It's a substituent from ANE to YL. Don't forget that. So you know this is what? A substituent. And it's being attached to what? These two means it's being attached to carbon number 2. So you come here, 1, 2, in naming. Yeah, there is a rule for numbering the carbon atoms. Yeah, as we go further, you understand it very well. I'll show you the rules. Yeah, so for now, this is it. We've identified the methyl group. Yeah, so this methyl group is attached to what? Carbon number 2. Carbon number 2. This is carbon 1. Carbon 1, carbon 2, carbon 3. This numbering can also be from here with reasons, which when we get to that you understand. Yes. So we have carbon number 1, carbon number 2, carbon number 3. So, and we see that our methyl group here is attached to carbon number 2. So what do? You bring down. Remember when I did something like this? Yeah. So this is it. See, you can write it this way. Yeah. When we'll be doing condensed formula, and you understand, we have so much to do. Yeah, but you understand it. We'll do it step by step. You take it step by step. You understand. Don't worry. This is it. So see, so this is the structure that was here before. Yeah. So this is what you put a hydrogen atom. 3 hydrogen atoms. This is a bond. Carbon to carbon. Have you seen any double bond here? You will not see any double bond because the name is what? Alkane. No, as you can see, there's no double bond here. Yeah, because it's not, this is ANE, not ENE or YNE. So this is it. You add your hydrogen atom. So you see 2-methyl, 2-methyl propane, 2-methyl propane. So even if you look at the name, you can get to the structure. They give you structure and you name it very well. They give you the name and you can write the structure very well. That is it. Very simple. So I want you to try this question for me. Practical question. Remember, before the next video, you have to do the practical question. Just try something on your own. You will understand it very well. So today our practical question is So number 1 question is what is an alkyl group? An alkyl group, you can call it alkyl. It's the same thing. Number two is how is methyl formed from methane? What is an alkyl group? Sorry, it should be there. How is methyl formed from methane? Number three, what suffix replaces ANE? What suffix replaces this when forming alkyl group? What suffix replaces ANE when forming alkyl groups? Okay. So drop your answers in the comments. Yes, I want you to try this very well. Thank you for watching. This is Kitchen Chemistry with Imabest.